All right, so check this out, everyone, because we may be in for a real show
Right.
in the sky the next few nights.
Yeah.
And I'm not talking about, another one of those satellite internet constellations going overhead.
Right.
We're talking auroras,
Yeah.
northern lights, but like not just your normal average aurora borealis.
Right.
We're talking potentially huge GE displays, visible way farther south than usual.
Yeah, you're not kidding. And you know what's really interesting about this isn't just like your normal run-of-the-mill aurora.
Okay.
This is looking like it could be the result of two separate solar events that are kind of happening to like line up perfectly.
Oh, wow.
So it's like a 1-2 punch from the sun.
It's like a celestial double feature, kind of.
Exactly.
I was reading this article on space.com, and it was talking about this double CME causing this potential aurora alert. And I'll be honest, when I first saw that headline, I was like, okay, is this hype, or is this really going to be something special?
It's definitely special. NOAA, they're the ones who like monitor all the space weather and stuff.
Yeah.
They issued like a G3 geomagnetic storm watch.
Okay.
Which, if you're like me and don't have those G scales memorized,
Oh,
that
yeah.
basically means strong. So it's a strong geomagnetic storm.
Okay.
Not the most extreme,
Okay.
but it's still strong enough that it could potentially mess with power grids and satellites and things like that.
Yeah, G3, that's enough to get my attention.
Yeah, exactly.
But before we get too far ahead of ourselves, can we rewind a little bit? The article kept mentioning CMEs, and that just sounds like something straight out of Star Trek.
Right.
What exactly are they, and like, what's the connection to the aurora?
Okay, so picture this. The sun decides to just have a massive sneeze,
Okay.
but instead of like spit and tissues flying out, what gets ejected is this massive burst of plasma. And so think of that as like superheated, electrically charged gas.
Oh, wow.
And then along with that plasma comes like this huge tangled mess of a magnetic field.
Oh, wow.
That's a CME in a nutshell.
So basically the sun just like hurls a giant ball of electrified fire at, well, us sometimes, I guess.
Pretty much, yeah.
Okay, so then how do those CMEs, like those solar sneezes, how do those actually lead to the northern lights? What's the connection there?
Okay, so you know how Earth has its own magnetic field?
Right.
It's kind of like this protective bubble around us. It's called the magnetosphere.
Right.
Think of it as like our planet's personal force field, deflecting most of the sun's radiation and stuff, right?
Right.
But then when a CME comes barreling in, it's like throwing a rock into a pond.
Oh, okay.
It's going to make ripples, or in this case, disturbances in that magnetic field.
Okay, so the CME hits our magnetic field, and then what? How do we get from magnetic ripples to, like, dancing lights in the sky?
So those ripples, those disturbances, those actually send charged particles from the CME like hurtling down toward the Earth's poles. And when those particles hit the gases in our atmosphere, they release energy in the form of light, and boom, Aurora Borealis, or northern lights.
Oh, wow. So it's almost like the CME is setting off this chain reaction, kind of.
Yeah.
Using Earth's own magnetic field and atmosphere to, like, make this light show.
Yeah, it's pretty wild.
That's incredible. And so this, we're not just talking about one CME, but two.
Exactly, like that. Remember that double sneeze analogy?
Right.
The article I was reading even had like a photo
right.
of one of the flares. That's like the technical term for those solar sneezes.
Okay.
It was taken by NASA's Solar Dynamics Observatory.
Okay.
And it's seriously like, it looks like the sun cracked open.
Wow.
You can totally see why they call it an eruption.
Okay, yeah, I just looked it up. That is intense.
Right.
So, like, it makes sense that two of those could make for a really spectacular aurora.
Yeah.
But the article also mentioned how unpredictable space weather can be.
Yeah.
So how sure are we that this is actually going to be a good show? Like, it's not like we can just check the aurora forecast on, like the Weather Channel app.
Right. Yeah. Predicting space weather it's definitely way more complicated than just your average rain or shine forecast.
Right.
Like, we can track the CMEs,
Right.
we can make educated guesses,
Great.
but there's always a chance things could change.
Okay.
It's kind of like planning a picnic only to have like a surprise thunderstorm roll in.
Right, right. Okay, so no guarantees, but what about this double CME situation? Like, does that change things at all?
It actually might, and this is where it gets really, really interesting.
Okay.
That first CME, the one from a few days ago, might actually pave the way, so to speak, for the second CME to have an even bigger impact.
Oh, really?
Yeah, it's kind of like that first one is almost like softening up Earth's defenses, so to speak.
Okay.
Making it easier for the second one to really, like, shake things up.
So wait, so the first CME could actually amplify the second one?
Potentially, yeah.
So instead of it being like two separate events, it's more like this 1-2 punch
Exactly.
that could be even stronger than expected.
Exactly.
Well, okay.
Yeah, I was actually reading a post by this space weather forecaster named Sarah Horacio,
Okay.
and she kind of put it in a way I thought was really helpful.
Okay.
She was saying that the first CME might precondition, basically like prepping the environment in a way,
Right.
so that the second CME can have a bigger impact.
Oh, wow. Okay, this is getting exciting.
Right.
So for those of us who are like actually hoping to catch a glimpse of this, like potential Aurora extravaganza, what are our chances? And like, what can we do to increase our odds of actually seeing it?
Well, first off, you're going to want to get as far away from city lights as possible. Right.
You know, light pollution is like the aurora's worst enemy.
Right, because even the most amazing, like, celestial display can't really compete with a street light.
Exactly. Yeah, it's like trying to watch fireworks during the day.
Right, exactly.
So dark skies are key.
Okay, dark skies, check. What else?
And then, of course, you'll need Mother Nature to cooperate, right?
Right.
Clear skies are absolutely essential for, like, optimal aurora viewing.
Right.
Because if it's cloudy, even the strongest geomagnetic storm won't do you much good.
Right.
So definitely check that weather app before you head out.
Okay, got it. Dark skies, clear skies, check and check.
Exactly.
Any other, like, pro tips for aspiring aurora chasers?
Let's see.
Like, are there any, like, tools or resources that could, like, help us out?
Yeah. So there's some really awesome apps out there.
That can make a world of difference.
Okay.
They give you, like, real-time updates on the geomagnetic activity,
Okay.
aurora forecasts that are tailored to your location,
Oh, cool.
and even alerts to, like, let you know when and where the show's about to begin.
Whoa. So no more standing out in the cold for hours, like hoping for a glimpse. Technology to the rescue.
Exactly.
What are some of your go-to apps for this?
Two that I highly recommend are my Aurora forecast and alerts,
Okay.
and then Space Weather Live.
Okay.
Those are both available for, like, iOS and Android,
Okay.
and they're super user-friendly.
Awesome. I'm downloading those right now.
Nice.
You know, it's kind of mind-blowing, though, how technology can just, like, connect us to these incredible events that are happening, like millions of miles away. We can literally have a front row seat to the sun's activity, all from our phones.
I know, it's crazy, right?
That's wild.
It really is incredible, but even with all the technology, there's still something really, like, primal about witnessing the Aurora Borealis, like, firsthand. It's just this very visceral reminder of, like, the vastness of space, the power of the sun,
Right.
and then just our own small place in this whole cosmic dance.
Beautifully said. Yeah, it's very humbling, for sure. And this particular event, with the potential for it to be visible so far south,
Right.
it feels like a really special opportunity, honestly, for people to, like, connect with something bigger than themselves.
Absolutely. And, you know, it's not just about, like, the visual spectacle, these geomagnetic storms, as awe-inspiring as they are. They also kind of remind us that we're not just, like, passive observers out here in space.
Right.
We're very much directly connected to the sun and its activity.
That's a great point. It's easy to kind of forget that
Yeah.
that we exist in this, like, incredibly dynamic relationship with our star. And, you know, like, we depend on the sun for, like, light, for warmth, for, like, life itself.
Right.
But it also has this potential for just, like, incredible power.
Precisely. Yeah.
And as we, like, learn more about the sun and its cycles, we start to understand just how, like, intertwined our lives really are with its every, like, breath. Essentially.
Boy.
This whole, like, double CME thing got me thinking,
Yeah.
what if this isn't just, like, a cool event?
Yeah.
What if it's like a sign of things to come? You know, the article mentioned that the second flare was the biggest since 2017.
Yeah.
Are we entering, like, a period of, like, increased solar activity?
That's a great question, and it's one that scientists are, like, constantly trying to answer.
Right.
Because, you know, the sun goes through cycles of activity, kind of like a cosmic heartbeat, if you will, where you have these periods of, like, relative calm and quiet, followed by these periods of, like, increased activity that are marked by more sunspots, solar flares, and, of course, CMEs.
The sun has, like, a heartbeat. That's kind of awesome.
It does. It's pretty cool.
But, like, seriously, does that mean that we're in for, like, a wild ride with solar activity over the next few years?
It's possible, yeah. So the current cycle, which, you know, scientists being scientists, they have to give it a fancy name, right?
Yeah.
So they're calling this solar cycle 25.
Okay.
It began back in December of 2019,
Okay.
and while it started off pretty quiet, it's
Mm.
been ramping up lately,
Okay.
and predictions are suggesting that we'll hit solar maximum, so that's kind of like the peak of the cycle,
Okay.
sometime around 2025.
Okay, so if this latest double CME event is any indication,
Yeah.
we could be in for some pretty spectacular, like, solar fireworks over the next few years.
Yeah, it's true.
But wait, those, like, fireworks, they're not always so harmless, are they?
That's a good point. Yeah, they can definitely have very real and sometimes serious impacts here on Earth.
Yeah, it's like we've been talking about these incredible light shows in the sky.
Right.
But we can't forget that those solar storms can actually have some real-world consequences.
Yeah.
Like beyond just, messing up our chances to see a cool aurora.
Right.
It's a bit of a reality check, isn't it?
It is, yeah. At their most extreme, these geomagnetic storms can disrupt power grids,
Right.
leading to blackouts.
Yeah.
They can interfere with satellite communications,
Right.
mess with navigation systems,
Okay.
even pose a radiation risk to, like, astronauts.
Wow.
Yeah.
Okay, so it's not just pretty lights in the sky.
Right.
There's like a whole other side to this.
Yeah.
It's like a reminder that the sun's power is like incredible.
It is.
And we're kind of at its mercy.
Yeah.
Like, what can we even do to protect ourselves? It's not like we can just throw a giant umbrella over the earth.
Right, yeah, it's a huge challenge.
Yeah.
But scientists are, they're working on solutions, whether it's, making our power grids more resilient,
Okay.
improving our space weather forecasting so we have more warning time,
Right.
even developing, like, early warning systems to give us a heads up before a major solar storm hits.
Right.
So, there's a lot of really brilliant people working on this problem.
Yeah, it's reassuring to know that they're on the case.
Yeah,
It's like we're constantly learning more about the universe
we are.
and at the same time realizing like how much we still don't know
Right.
and how much we need to like prepare for.
Exactly.
You know what? You've got me wanting to bundle up,
Yeah.
grab my phone with those Aurora apps that we talked about
Yeah.
and find like the darkest sky possible.
I hope you do.
Yeah.
And hey, if you manage to catch a glimpse of this, like, double CME extravaganza,
Right.
you gotta take some pictures.
Oh, deal.
Yeah.
And for our listeners,
Yeah.
even if you aren't, in a good spot to see the Aurora,
Right.
you should really check out like the photos in that space.com article that we keep mentioning.
Yes.
We'll be sure to link it in the show notes.
Please do.
This has been an incredible deep dive.
It has.
We started with a simple Aurora alert.
Right.
Then we dove into CMEs, solar cycles, like the works,
Yeah.
all because of our sun deciding to just put on a little show.
A little show, right.
Yeah, exactly.
It's a perfect example of why we love these deep dives.
Yeah.
They take you to unexpected places. Who knew? Like, a little solar snooze could be so fascinating.
Right. Yeah, exactly.
Yeah.
And on that note, we'll leave you with this final thought. We talked about how, like, the sun has its own cycles,
Right.
how its activity, like, rises and falls over time.
Yeah.
And right now, it looks like we're heading towards a peak in solar activity in the next couple of years.
We might be.
So think about this. What could that mean for us here on Earth beyond just more auroras?
Right.
What other impacts might we see as the sun, like, really gets active?
Yeah.
Something to ponder as you look up at the sky,
Do
whether it's, lit up with the aurora or just, shining with starlight.
Right.
Until next time, keep looking up and keep asking those questions.
Mm-hmm.